Hello everyone, my name is Brian, and today I'll be discussing the discrete time Fourier transform, or DTFT. What is a DTFT? What a DTFT basically does, it takes this discrete signal and turns it into a frequency domain representation of the signal x of n. This is basically what the frequency response is, and it is also represented as capital X e to the j times omega. There are two main equations you have to know for a DTFT. The analysis equation, which takes in a signal and gives out the frequency response, and the synthesis equation, which takes in a frequency response and gives you a signal. This will all make sense with this example. With this example, it says find DTFT. So we are just focusing with the analysis equation. We are given a signal that says that it equals 1 from 0 to 3 and it equals 0 otherwise. I've drawn a picture here to give you guys a better representation of the signal. So what we want is to turn our discrete time signal into a frequency response. So we use the analysis equation, and we know that from 0 to 3 it equals 1, so we plug that in here. We plug n is equal to 0 to 3 of x of n e to the negative j omega n. Now we find the expansion of this, and we get this here. And from this, we simplify a little bit more, and we get 1 plus e to the negative j omega plus e to the negative 2j omega plus e to the negative 3j omega. But there's a problem with this. We can't find the phase or magnitude. So we have to use the series expansion. The series expansion is shown here. Basically, we have to make the frequency response look like this right here. So we have x of n, and we can change that to replace that with the 1, because we know that from 0 to 3 it equals 1. Then also we can see that for c, we have e to the negative j omega. So c is equal to the negative j omega, and n minus 1 is going to be equal to 3. So n minus 1 is equal to 3. So now we know that n, the n we have here, the n is going to be equal to 4. So then when we put all this together, we have 1 minus e to the negative 4j omega divided by 1 minus e to the negative j omega.